Let's begin with differentiation introduction. So basically, what is differentiation? Differentiation is a method of finding the derivative of a function. There are three techniques to solve differentiation problems. First, derivative of sum and difference. Second, derivative of a product function that we use a product rule. And lastly is a derivative of rational functions that we use a quotient rule. So apart from related rates, there are four more applications of differentiation. First is analysis of function 1, increase, decrease, and concavity. Analysis of function 2, relative extrema, first and second derivative test, applied maximum and minimum problems, and lastly is Rolle's theorem and mean value theorem. So let's move to related rates. What is related rates? Related rates is a problem that involves at least two changing quantities. The idea is to find the rate of change quantity by relating that quantity to another quantity whose rate of change are known. The rate of change usually with respect to time.
Steps to solve related rate problem. Number 1. Draw a representation of the problem. Number 2. Write an equation that relates the quantities of interest. Number 3. Differentiate both sides of the equation with respect to time. Number 4. Substitute the rate of change and the known quantities into the equation. And the last one, solve for the wanted rate of change. Now let's get to the example 1. Example 1. A spherical balloon is deflated at a rate of 10 cm3 per second. Find the rate of change of the surface area when the volume is 32/3 pi cm3. So the first step is we will list down all of the information that been given in the question. The first one is dV/dt is equal to negative 10 cm3. The reason it is negative 10 because in the question it says the balloon is deflated at a rate of 10. Deflated means it is negative. And then what we want to find is dA/dt when volume is 32/3 pi. Jump on to the next step. We will write an equation that satisfies dA/dt, which we will get dA/dV times dV/dt. Since dA/dV is impossible to find, we will write and break it down to dA/dr times dr/dV. You may be asking, where did I get dr? The reason I picked dr is because if you know, in the formula of sphere for the area and the volume, there is r in the equation. Let's go into the third step. The third step, we will find dA/dr and the differentiation of the volume and the area. As you can see, 4 pi r square. If we differentiate it, it will be 8 pi radius. And same goes to the v. If we differentiate it, it will be 4 pi r square. Then we will substitute it to the equation we made before. Since dr/dv is different from dv/dr, we will put 1 at the top. So it will be 8 pi r times 1/4 pi r square times negative 10. Negative 10 is the dV/dt. In the fourth step, we will find the r. If we take the formula for the volume, 4/3 pi r cube is equal to 32/3 pi. Why it is 32/3 pi? It is because in the question it already said when the volume is 32/3 pi. So if we calculate it, we will get r is equal to 2. So in the last step, we will simplify the equation and it will be 2/r times negative 10. Since we already got the r, we will replace it, and the answer is negative 10. So the final answer is negative 10 cm square.
Example 2.
A conical water tank filled with water has a radius of r cm at the top and h cm height. A. If the height of the water is twice the radius, show that V equal 2 over 3 pi r cube. First, we have to know the volume. So the volume for a conical water tank, which is the cone, is 1 over 3 pi r square h. So the height of the water is twice the radius, which means that h is equal to r. So V equal 1 over 3 pi r square minus 2r, we can get 2 over 3 pi r cube. Now we look at question B. Water flow in the tank at a rate of 15 cm cube per second. How fast is the radius changing when the radius is 4 cm? So dV over dt is equal to 15 cm cube per second. The radius changing, so the radius is dr over dt is equal to what? When radius is 4 cm. So dr over dt I separate into 2 and get dr over dv minus dv over dt. We know that dv over dt is 15. So from the volume, we differentiate it and get dv over dr equal to pi r square. Therefore, dr over dt is equal 1 over 2 pi r square minus 15 and get 15 over 2 pi r square. When the radius is 4, therefore, dr over dt is equal 15 over 2 pi minus 4 square. It becomes 15 over 32 pi cm per second.
Conclusion. The application of differentiation is used to compute the rate of change using geometry formula. We can accurately count the difference in change that happen by applying the chain rule method or implicit method to solve the question.
We are really grateful because we managed to complete this video presentation within the time given by our lecturer, Ms. Hidayah. This assignment cannot be done without the extraordinary cooperation and effort of our group members. We are also very thankful that Ms. Hidayah gave us a lot of guidance and help in completing this assignment, and definitely to teach us in this course. Last but not least, we would like to express our gratitude to our family members who have always given us encouragement and support over the time.